Imagine a place in the universe where gravity is so strong, not even light can escape its pull. What comes to mind? Yes, you've got it. We're talking about black holes, and they're far more fascinating than most can fathom. Picture an event horizon, a boundary beyond which nothing, not even light, can escape. Consider their mass and size, their singularity, a point of infinite density. And did you know some even rotate, curving the very space around them? Intriguing, isn't it? Welcome to the enigmatic world of black holes. What makes a black hole so unique and mysterious? Let's delve into its features. At the heart of a black hole's mystique is the event horizon, the boundary beyond which nothing, not even light, can escape. It's like a cosmic point of no return. Once an object crosses this threshold, it is inexorably drawn into the black hole, never to emerge again. Now, black holes aren't one size fits all. Their mass and size can vary dramatically. Some are just a few times more massive than our sun, while others, known as supermassive black holes, can have masses equivalent to millions or even billions of suns. And here's the kicker. As the mass of a black hole increases, so does its size. Within the heart of a black hole lies an enigma called the singularity. This is a point where, as far as we understand, density becomes infinite. It's a concept so extreme that our current understanding of physics can't quite grapple with it. But black holes aren't just sitting still, some of them spin, rotating around their own axis. This rotation can be so powerful, it warps the space around the black hole, adding another layer of complexity to these already mind-boggling entities. And then there's the somewhat counterintuitive concept of Hawking radiation. Named after physicist Stephen Hawking, this theory proposes that black holes aren't entirely black, but emit small amounts of thermal radiation. This means that given enough time, a black hole could lose energy, shrink, and finally evaporate entirely. So, black holes are more than just cosmic vacuum cleaners. They're incredibly dense, spinning entities, surrounded by an event horizon from which nothing escapes, potentially radiating energy as they slowly evaporate over time. Each feature contributes to the overall understanding of black holes, and yet, they still hold many secrets. Their extreme nature challenges our understanding of the universe and continues to inspire awe and curiosity. Now that we've explored the fundamental features of black holes, let's classify them into types. Black holes come in different sizes and masses, from supermassive to micro black holes. These celestial entities can be broadly categorized into three types, each with its unique characteristics and locations in the cosmos. First, let's talk about the heavyweights, the supermassive black holes. Supermassive is no understatement. These black holes are extraordinarily massive, with masses equivalent to millions or even billions of suns. You'll typically find these giants lurking at the centers of galaxies, exerting their gravitational influence on stars and gas around them. Our own Milky Way galaxy is believed to host a supermassive black hole, right at its heart. Next, we have the intermediate mass black holes. These are the middleweights of the black hole family, with masses ranging from thousands to millions of solar masses. They're like the Goldilocks of black holes, not too big, not too small, but just right. And where do you find these intermediate mass black holes? They're often discovered at the centers of star clusters, governing the motion of stars within these clusters with their gravity. Finally, let's shrink down to the smallest members of the black hole family, the micro black holes. Despite their name, these black holes pack a punch. They have atomic dimensions, yet their mass can be as much as a mountain. These tiny black holes could be remnants from the early universe, offering us a glimpse into the cosmos's infancy. So, from the colossal supermassive black holes at the centers of galaxies, to the medium-sized intermediate black holes within star clusters, and down to the tiny but mighty micro-black holes possibly left over from the universe's early days, black holes truly come in all shapes and sizes. Each type of black hole presents unique characteristics and mysteries, but how do we even know they exist? Black holes, while invisible to the naked eye, show their presence in other remarkable ways. One of the key methods of detecting black holes is through the observation of gravitational waves. Now you might be wondering, what are gravitational waves? They are ripples in the fabric of space-time caused by the most violent and energetic processes in the universe, such as the collision of black holes. This is where LIGO, or the Laser Interferometer Gravitational Wave Observatory, comes into play. LIGO has made groundbreaking discoveries by detecting these gravitational waves, providing evidence for the existence of black holes. The gravitational waves detected by LIGO have opened up a new way of observing the universe, allowing us to perceive phenomena that were previously invisible. Now, aside from gravitational waves, black holes can also be observed through X-rays, radio waves, and other forms of radiation. You see, when a black hole feeds on matter from a nearby star or gas cloud, it creates a swirling disk of superheated material around itself, known as an accretion disk. This disk emits radiation across the electromagnetic spectrum, which we can detect with our telescopes. One of the most fascinating discoveries in this field is the presence of a supermassive black hole at the center of our own Milky Way galaxy. This black hole, known as Sagittarius A*, has a mass equivalent to about 4 million suns, yet it fits within a volume smaller than our solar system. Observations of stars orbiting around this invisible point have provided strong evidence for its existence. Despite these significant strides, our understanding of black holes is still in its infancy. Their extreme conditions challenge our fundamental theories of physics, including general relativity and quantum mechanics. As we delve deeper into the study of these cosmic beasts, we find more questions than answers. Even with all our advancements, black holes remain largely mysterious, prompting endless questions and opening doorways to new research. Journeying through the world of black holes, we've unraveled some of their mysteries, but many more remain. From the inescapable event horizon, to the mind-boggling singularity, and the theoretical Hawking radiation, black holes continue to captivate us. Be they supermassive, intermediate, or micro, each type poses its own set of questions. And as we strive to detect their presence and study their behavior, we're reminded of the vastness of our universe and our quest to understand it. As we continue to probe these cosmic enigmas, who knows what secrets they'll reveal next? Until then, keep looking up and wondering.